Good morning, everybody, and thank you so much for watching this video, okay? Remember that at the end, I want either a thumbs up, a thumbs down, or a suggestion that I can do to improve my recordings, okay? So we have lesson 2-3, scientific notation with negative powers of 10. So the essential question is, how can you use scientific notation to express very small quantities? So yesterday we did very large quantities, 10 to the power of 6, 10 to the power of 8. Now it's going to be little tiny quantities. How do you write those numbers? What's the tiniest number that you can think of? Think about it, okay? So now let's watch this video.
Is the Earth big or small? Sounds like a pretty silly question, huh? Looking at it from our point of view, the Earth is gigantic. But astronauts get to see it from a different perspective. To try to get some perspective without going to space, we can look at it like this. The volume of the Earth is about 7/10 times smaller than the volume of the Sun. Okay, that's pretty small, and it's quite a mouthful. How can you express the Earth's volume in comparison to the Sun's in a way that is easier to work with? This is where scientific notation comes in really handy. In this lesson, you'll learn how to use scientific notation to express this type of relationship.
Okay, so then you got a tiny number right there, right? 0.000007. You know, again, my take on this is that the reason why mathematicians invented the scientific notation is because they didn't want to write too many zeros. So that's why this method was invented. But that's just my thinking, okay?
What does moving a decimal point one place to the left do to a number?
Let's see. Let me show you my calculator. Okay, so let me show you this one. Okay, I'm just going to start with like something easy. Okay, 2,300. Okay, like 2,300. And I'm just going to press enter. Okay, now, let me see. Let me do this something. 2,300 equals, if I write it in scientific notation, it'll be 2.3 times, or I'll put times 10 to the power, we learned it yesterday. After the 2, there's 3 digits, so I'm going to put to the power of 3. Okay? And then I'm going to enter that, okay? Now, if I have 230, what would that be in scientific notation? It'll be 2.3 times 10 to the power of 2, because there's 2 numbers right after the 2, okay? Now, what do you notice? What is happening right there? Look, what happened to the exponent? Now, if I just put 23, and then I put equals, that's going to be 2.3 times 10 to the power of what? Well, I only moved it once, right? It was right after the 2, so it's going to be the exponent is going to be 1. Oops, just 1. What will happen if I have 2.3? What would that be? That would be 2.3 times 10 to the power of. Now let's look at the patterns. What do you see on the exponent? We started with 3, 2, 1. What's the number after 2, 3, 2, 1? Hopefully you got it. So it'll be 0. Oops, 0. Now my big question is, what will happen if I have 0.23 equals, okay? I notice the coefficient is still always 2.3, 2.3. So I still have to put in scientific notation, I still have to put in 2.3. But now what would be the exponent? What patterns do you see? So we went from 3, 2, 1, and then 0. What's that number? What's the next pattern? So yes, it is -1. And then we go down to -2, -3. So guess what? Really, really tiny numbers have negative exponents in scientific notation. Once we write them in scientific notation, they have negative exponents, okay? So let's go back over here. What was the question? The question was, what does moving a decimal point one place to the left do to a number? It increases the number by 10, decreases the number by 10, multiplies the number by 10, or divides the number by 10. I was about to say decreases the number by 10, but it's not really. It's dividing by 10. Okay? Because like if I have 100 and then I go down to 10, no, let's do something else. If I have 200 and then I move the decimal place over. Let me show you. Let me show you right here. If I have 200 and then now instead of 200, I only have 20. How did I get 20 from 200? I divided it by 10. Okay, it didn't decrease it by 10. I almost was going to say that, but it divides the number by 10. Okay.
Good job. Moving the decimal point one place to the left divides the number by 10. What does dividing a number by 10 do to an exponent with a base of 10?
We just noticed that, right? What did it do to the exponent? So right there, you can see the exponents. It went from 3, 2, 1, 0, negative 1. So the exponent was decreased by 1, okay? So decreases the exponent by 1. Not the base, the
Great job. Dividing a number with a base of 10 by 10 decreases the exponent by 1.
And any questions? If you're confused, send me an email, a text, or let me know.
Multiplying a number by a power of 10 is as simple as moving the decimal point a certain number of places. The exponent tells us the number of places we must move the decimal point. The sign of the exponent tells us which direction to move.
So since this is 0, then that means I'm not going to move the decimal at all because the exponent is 0. 10 to the 0 power is 1, and then 1 times 1.345. Well, it's just going to be 1.345.
For example, 1 345 thousandths times 10 to the 0th power is still 1 345 thousandths. We do not need to move the decimal point. When the sign of the exponent is positive, we move the decimal point to the right. The exponent tells us the number of places to move. Now, find the missing exponent.
I don't like to give you rules. Remember that you can always use the calculator, but when you use the calculator, I want you to think about what is happening, okay? What is happening? And you know what? I'm going to show you, let me see, 1.345 times 10 to the 0 power. Let me show you the calculator. So this one is going to be 1.2, what was it? Let me see. 1.345. 1.345 times 10 to the 10 to the 0 power. Look, what happened? Nothing. Okay, now we're going to change that from 10 to the 0 power to 10 to the first power. What do you notice? Oh, look at that. It went from 1.345 to 13. Now what's going to happen when we have to the second power? The decimal moved over to the right again. And how about if we go to the third power? Okay, so notice here, it moved, you can see right there, it was between 1 and 3, then it was between 3 and 4, then it was between 4 and 5, and then there's no decimal. Guess what? There's always a decimal, but it doesn't show it. When the decimal's at the end right here, it doesn't show it. So it's 1, 3, 4, 5, bam, decimal right there, okay? So that's how it looks. So now here we can say, well, it moved from 1.3 to 1, 2, 3 places. So that means to the 3 places. Another way is you can look at the pattern here, 0, 1, 2, 3. So always look for at least 2 different ways, okay?
That's right. 1 345 thousandths times 10 to the third power equals 1,345. Let's see what happens when we multiply powers of 10 that have negative exponents.
Ooh, I like that. Well, let's use the calculator. Well, we already had the 0 right here. What happens if I go backwards right here? And instead of putting in 1, I'm going to put in -1. Oh, look it was between 1 and 3. Now it's in front of the 3. Now let's go back in here and let's see if it is -2. Ooh, it moved even over 1 to the left. Or right here, this was -3. Ah, look it, they started putting zeros in the front. So look, if it was 0, it stayed the same. If it was -1, the decimal moved one unit to the left right there. If it was -2, the decimal moved 2 units to the left. Now, in math, whenever there's a decimal, we always put a 0 in the front to remind people, hey, there's a decimal right there. Hey, there's a decimal right there. Okay, so that's why you see that 0 in the front. Okay, awesome. I love this. So what's going to happen? It's going to move the decimal that many places to the left.
When the sign of the exponent is negative, we move the decimal point to the left. The exponent tells us the number of places to move. Now find the missing exponent.
So there's 2 different ways. I can count right here. I can count the loops. So there's 1, 2, 3, but it's to the left, so it's going to be negative. I can count right here. I can see the pattern, 0, -1, -2. Oops, the next one's -3.
That's right. 1 and 345 thousandths times 10 to the negative third power equals 1,345 millionths.
Lots of patterns to see. Yay.
A typical human hair has a diameter of 25 millionths of a meter. Write this number in scientific notation. Move the decimal point and 25 millionths to the right as many places as necessary to find a number that is greater than or equal to 1 and less than 10. What number did you find?
So once again, remember that the coefficient, the beginning number on the scientific notation form, is going to be a number that is equal to 1 or less than 10. So when I look at that, I see the number that stands out to me is the 25. So the 25, how can I make the 25 a number between 1 and 10, or equal to 10 or greater than or less than 10? So the only way is I can put a decimal in between it. So it's going to be 2.5. Okay, 2 and 5 tenths.
That's right. The answer is 2 and 5 tenths. Divide 25 millionths by 2 and 5 tenths. What is the answer?
So I can divide that, but I can also see, well, I moved the decimal, how many? 1, 2, 3, 4, 5. So that means I moved it 5 places. So let me see, that one has 1, 2, 3, 4. Nope. This one has 1, 2, 3, 4, 5. Yep, I think it's this one. 1, 2, 3, 4, 5, 6. So I'm going to go with the middle one.
Correct. 25 millionths divided by 2 and 5 tenths is 1/100,000th. Now write your answer as a power of 10.
So remember, it's a very tiny number, so we use negative exponents. So that's how many numbers did I move it? 1, 2, 3, 4, 5 digits. So it's going to be 10 to the -5. Okay? And you can use the calculator to check it.
That's right. 1/100,000th can be written as 10 to the -5th power. What is 25 millionths written in scientific notation?
So my coefficient will be 2.5, and then my exponent is going to be -5. So it's going to be this one. So remember, this is the coefficient, the exponent is -5, and then the 10 is called the base.
That's right. 25 millionths can be written as 2 and 5 tenths times 10 to the -5th power.
Any questions? Let me know.
To write a number between 0 and 1 in scientific notation, move the decimal point right and use a negative exponent.
Okay, so move it to the
right. To write 783 10,000ths in scientific notation, move the decimal point 2 places to the right.
So then right here, to make it a number less than 10, the decimal has to be between 7 and 8. So I know that it's going to be 7.83. And then, well, you moved it 2 places, so it's going to be times 10 to the -2 place. Okay, 10 to the -2.
The average size of an atom is about 300 millionth centimeter across. Write the average size of an atom in scientific notation. Move the decimal point to the right to find a number that is greater than or equal to 1 and less than 10. First, click the location and the number to place the decimal point.
So I see that 3, well, 3 has to, it has to be 3, so the decimal has to go right after the 3. So they already have it correct right there. Oh, they didn't have it? Now I could, okay, I thought I had it right there. So I can check it now.
That's right. The decimal point goes to the right of the 3. Next, count the number of places you moved the decimal point.
So it was way over here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So I see 8. So I moved it 8 times.
Right. You moved the decimal point 8 places. Finally, multiply 3 and no tenths times a power of 10.
So I know that that number is very tiny, so my exponent is going to be negative. When I write really big numbers, the exponent is going to be positive. When I write really tiny numbers, the exponent is going to be negative. So that's going to be negative 8, okay?
That's right. Multiply 3 and no tenths times 10 to the negative 8th power.
Okay, and any questions, any confusions, put it on the comment for this video.
To translate between scientific notation and standard notation with very small numbers, you can move the decimal point the number of places indicated by the exponent on the power of 10. When the exponent is negative, move the decimal point to the left. A typical platelet has a diameter of approximately 2 33 times 10 to the negative 6th meter. Write this number in standard notation. First, write the number of places to move the decimal point.
Okay, so they're giving you guys so many rules. I don't memorize rules because my brain wouldn't work. But right here, right away, I notice when I look at 2.33 times 10 to the negative 6, my thing that stands out, it's that negative 6. Oh, it's going to be a very tiny number. So that tells me that, it's going to be a very tiny number. So that means it's going to be 0.00 something probably because it's a very tiny number. So how many places do I move it? That negative 6 tells me it's 6, okay? Check my answer.
Right. Move the decimal point 6 places. Next, place the decimal point. Since you are writing a number less than 2 33 move the decimal point to the left.
And
Add placeholder zeros if necessary.
for me, I can't memorize left or right. Sometimes I even don't know which one is my left and which one is my right. But I know that this is a very tiny number, so it's going to be 0.00 something. So I start counting at the 2, and then I go, okay, 6 places. 1, 2, 3, 4, 5, 6. It was already there. I'm confused. Okay, so I put it right there, and then I'm going to check it.
That's right. There will be 5 zeros after the decimal point. Here is the standard notation of the number 2 and 33 times 10 to the negative 6th.
So it's a very tiny number, the zeros go in the front. If it's a very big number, the zeros goes at the end. That's my strategy.
Now, let's practice with the...
So number 1, it says complete the description for how to write that in scientific notation. So move the decimal point 5 places right to find what number am I going to. So I need a number that is equal to 1 or less than 10. I see the number 294. So how do I make that 294 equal to 1 or less than 10? So I put the decimal 2.94. Okay. Then multiply 2.94 by 10 to the, it's a very tiny number, so my exponent is going to be negative. And since I moved the decimal, how many places? I count from 2 to that decimal where it is. So it's going to be 1, 2, 3, 4, 5. So it's going to be negative 5 using a negative exponent on 10 that equals the number of places you move the decimal. Now, did I have to put the negative multiply negative? I wonder if I need that negative 5 or just positive 5. Well, I'm going to check it first. Well done. Yay, I didn't need to put that negative right there. Okay, the next one, it says, drag and drop the following numbers into the boxes to order them from least to greatest. Ay, 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 least to greatest. So remember, when you're ordering least, the smallest one is going to be with the negative, like a huge, the biggest negative exponent that I can think of. So when I look at these, the first thing I look at is I just look at the exponent. Look, -1, 2, -2, -3, -2. So I know that this one, the 2, is going to be the biggest one because it has a positive exponent. This one, the -3, is going to be the smallest one because it has a negative exponent. So I'm going to put it right there. Now, these two are in between, like right after that one, but I know that -1 would be bigger than these. So then it's going to be right there. So now I got to choose between these two. They have the same exponent. So now I got to look at the coefficient. Well, which one is smaller, 2.0 or 3.0? Ay, ay, ay. Technically, this is bigger. Would that be? Let me see. If I'm not sure, I can always use my handy dandy calculator. Let me see to see which one is bigger. Let me see. So it is 3.0 times 10 to the -2. -2 is right there. And then I have 2.0 times 10 to the -2. So which one is smaller? 0.03 or 0.02? This one is smaller. 2 cents or 3 cents? So 2 cents is smaller. Okay, so you can always check, but you got to think now. Which one? This one was smaller and this one was bigger. So I looked at the exponents, they were the same. So then I looked at the base to see which one was smaller and bigger. 2.1 was smaller, 3.0 was bigger. So then that's how it should be. Let me see, did I get it right? Yay! Thank you so much for watching.